I'm the Chief Technology Advocate for Google. I'm also the CTO of the Geo team, and I'd like to talk to you about several things today, basically three broad ideas. But the overall idea is that a lot of times we get busy doing, and it's possible to forget why we're doing. I want to talk to you a little bit about what Geo is about, why the parts we do, we've done the way we've done them. Hopefully those were wise choices, but in any case they were inspired choices for a reason. I'm going to share the reason with you, and that will hopefully make your guesses about our future choices more clear. And so we're going to talk through some of those things. And I'll take questions several times, and at the end, mostly. So let's get a start with that and see how this goes. One of the really important things in Geo, the Geo team at Google, is about information and context. If you look at all the things we do in the Geo track we're talking about today and tomorrow, things that have already been talked about this morning, they may seem like different little pieces of a puzzle. The puzzle, when you put it together, it communicates information and context. And let me tell you how big a deal that is to us. Information itself, some people are so maniacal, sort of the lunatic fringe of information society, that they think it actually is the fundamental nature of society itself. Thomas Jefferson was one of those people, and he said that basically the shining light, and when he always wrote about shining light, that light was knowledge. He said he had to do education so there would be a light for the populace. That this light is so important. And we have an optimism at Google that informed people make good decisions, that informed people live better lives, and that if we can inform people, we're doing them a favor. And in particular, in our part of Google, we want to put that information in context. And the way we do that at Google is we have a mission about organizing the world's information to make it universally accessible and useful. And I colored in the different parts of that because it's not just a slogan. Each part is important. So organize for us means what you might think of as search, which would be an index and a sort, a rank by some importance, and then sort. The top 25 would be page 1 of the search results, and the next 26 through 50 would be page 2. But that could be other ways of organizing. If you've ever used Google Trends, you can search for what people search about. And you can see a chart, like a histogram of search frequency. That's an organization. It's a frequency distribution organization. Google Photos, Google Image Search shows a mosaic of images as a search result. There are many ways to organize data. The thing I care about in the next part there, we're talking about what is that information. And in particular, it's the world's information. It's not Google's information. And that's an important distinction because sometimes when you look at our maps, our roads that we draw and the labels we put, you might think that that's what we're trying to do, is to build a really nice map. That's not what we're trying to do. That's very important. What we're about is organizing the world's information. For some of you developers, it's your information. So if you're the Wells Fargo Bank ATM location person, then your information is where the ATM machines are. That's what we want to organize. We just don't think you can draw it very reasonably if there's not a map underneath it. Our map is to make your data more valuable, to provide context, to make it more understandable. And that's mostly it. So we do gather information. We do have some Google information, so to speak, from our friends at Digital Globe and TeleAtlas and Navtech and Spotimage. But it's really not about us. We're going to talk about that a little bit. The next thing is this universally accessible part. That's probably the most burdensome aspect of the Google mission for us as engineers. Universally accessible implies, universal always is bad if you're an engineer, but because engineering is about making specific choices, weighing off good and bad for some desired case. So universal is almost like a lie to start with, but universal is about every language, wherever you happen to be. So if you're walking down the street and you pull out your phone and you speak Swahili, our founders think it's our job to help you, right? And that's pretty hard. That isn't just showing you a map. It's showing you, in the case of maps, it's particularly hard because you've got, a few thousand languages, of which a few hundred are most popular. You've got a few, maybe 10 million, 20 million places that have names. So you don't just want to know Tokyo in English. You don't just want to know it in Nihongo either, because If you don't speak Japanese, it's not going to do you any good. So you don't want the diagonal, Tokyo in Japanese and Rome in Italian, Roma. But you really want the whole matrix filled in, which is just very inconvenient as an engineer. And then the final part, but we have plans for that. The final part is to make it useful. And Thomas Jefferson was satisfied that if he changed the world of how things were done in government and give everybody a free education, not just wealthy people, that people would just learn, they would be smart, they would read political dialogues intelligently, and they would have nice debate. And he was that kind of guy, so he would expect that. He would project that onto people. It turns out that just because you have data, you don't necessarily have knowledge. So this insight generation, what Alfred North Whitehead thought of as this a useful application of information, is hard to come by. And so we take that useful part as our part of the mission at Google. The Geo team does. The people you'll be seeing spoke this morning, speak the rest of the day. And largely, a lot of people at Google, how can we make it more useful? Is there a way we can show it? Is there not just more available, not just more of it, and not ranked better, but somehow fundamentally more useful? And for our team, that picture on the right kind of shows you what we think. We think if you could see it in context, on a globe or on a map, if it's appropriate kind of information for that it might be more useful. So my first example of that is a little movie for you.
Sunday afternoon, I was driving into the station. We had just found out about the fires, and we were just finding out what was going on. It was the end of October. It was Santa Ana season. It had been a really dry year, and I was having flashbacks to the last time this happened. And the first thing that came to my mind was, what do people want to know? Where's the fire? How do we tell them that on a map? It started out just as a, this is where the fire is. Here's the evacuation center. This is what we know.
The map started taking off really quickly. A lot of other people were making maps, but for whatever reason, ours kind of latched on, and people started linking to it pretty quickly. It was in the millions of views within a day or two.
It's one of those rare instances where you sort of see the future in an instant, and you look at that and you just go, "Oh my God, this is so useful." Radio is a linear thing; it comes and goes. Whatever we were saying would just vanish. The map was a repository. The map really aggregated as much information about the fire as we could get.
Google's made it pretty easy in terms of offering, copy-paste embed code. It's pretty intuitive. Sign up for Google, go to Google My Maps, drag a marker here, type it in, save, and there it is. So it's not like you have to be some super geek.
There were really only a few options, a few buttons to click, a few different types of tools. Once we had the maps from some semblance of, fire burn area, used the polygon tool and just drew on, the area. So it was pretty much that simple.
So the ability to go in and search for an address or for a city name and then see where it is in relation to the catastrophe was really valuable for people.
They wanted to see, am I evacuated, and am I in danger of losing my house?
And so as we were getting more and more calls come to the radio station and we're gathering that information, then it would end up on the map itself, and over time we were able to see a much more complete picture of the fire. We could then look at the map and say, there's a pretty good guess that this community over here is next to be evacuated.
This map was live and constantly updated. It was very different from what you would see from other media.
I think it was kind of the right thing to do because, there's probably other mapping software out there, but just the Google name kind of has that brand associated with it, and it's visible.
Our map was on the CAL FIRE website. They embedded it on their homepage. I think I heard the governor's site had it. Port of San Diego had it. So the fact that we sent people out to the map on the Google site allowed other organizations to embed it.
It's all free, and everything's really well documented. There's usually a video to anything you want to learn. There's a good community around it.
It was a great experience for us. We were amazed by the way that it took off and the attention that it got. I was joking that we're like the little public media station that could. We were just trying to get the information out there, and it just took on a life of its own.
Okay, now, those people work at the San Diego Public Radio Station. They're not, good enough, engineering-wise, to come to an event like this, right? They used My Maps, and they just used the regular product, and they clicked on My Maps, and they updated data, and people call in, and they publish that. So that would be the weakest technology that we offer to make the data more useful. But it still made the data more useful. The latitude and longitude of the fire site, or some point along the fire boundary polygon as a shapefile, isn't really useful to most San Diegans. But this living truth that they could all access was a big deal. So that's the I think it's awesome. But that's just the start. Because people here can write JavaScript code. They can write ActionScript. They can actually do things. They can compile programs sometimes, even in moments of desperation. So it's not. We can aspire to do more, but I want you to understand what it means to be useful. So in this case, it was the public radio station, no money, no programming skill, just kind of a do-good spirit, making a big difference in the lives of 1 million or so people and touching several million people per day. The number they saw on their views isn't the real number because when we saw how many views they were getting, of course we upped their key, but we also started caching things for them in Google servers around the world so that they wouldn't, the things would work a little bit better, and so the view count doesn't really match up. It was 3, 5, 10 million views, but the key is that was like an indigenous mapping activity, connecting the knowledge that people in the area had with the underlying map. So it wasn't really a map. It was like a group phone call that had a graphical nature to it. And that's the kind of applications that I'd like to see us all, when our screensaver isn't acting up, I'd like to see us all build. And I'm going to talk to you about that. So let's look at an even more sophisticated way to do that. So if you look at this, these are some things that we did in the Google Maps. And in the background there is Paul Rademacher's housingmaps.com. The simple My Maps feature in Google Maps, which is not really, we don't think of it as a developer tool, to KPBS was a developer tool. All right? So one thing to think about as a developer is there's all kinds of users, and some of them are like junior developers. If you can meet their need, you've done a great job. These are some things we've built. The ones in red are some of the newer ones. The idea here is to either make more of the information available, to make it more universally available, make it more easy to get to, or to make the pieces more granular or sort of finer grained so that you can actually assemble with more variety to make your applications more powerful for the needs you anticipate. So, for example, the Static Maps API is the least sophisticated API we ever dreamed of. It's basically a URL to a JPEG image that happens to have a funny name that sort of like lets you geocode something and get back a map of the size you want. So anything that's a picture on a website anywhere in the world on a web page could be a map, custom made for you by just giving a funny name to the picture. And we found that some users wanted to do that. Obviously not, Flash developers, obviously not JavaScript, Ajax developers, but some people wanted to do that, to put on their news stories, to have a little picture there. People read the story, they get context. Some of them are more sophisticated. We just are announcing here this Gdata Api so that you can access My Maps type things, store things, upload things, download things, change things from code you build. We have a variety of pieces and tools we'll talk about here at the show. Those work together. I guess what I'm trying to get at is they work together in a very important way, and we've aspired to do a good job on your behalf in the way we weave these pieces together. Karl Marx commented once that the substructure defines the superstructure. And what he was commenting about was interesting, I thought, was we might think of atoms as building blocks, and you can't really see much, manganese when you look at this railing. the scale of an atom compared to the scale of things we deal with is so vast that there's not much structure from the substructure. But if you imagine a brick building made of bricks that were 8 feet cubed, then the rhythm of windows and doors would be very much defined by the bricks, because the bricks, the atoms in that case, are not that dissimilar to the scale of the molecule. A lot of the things that we build as Google are more of this large scale. So if we have a map window, if we have Google Sky, and it has Hubble data in it, and you use that in your application, it's very likely that a user will see the Hubble data sort of like they would see it in our products. It's not like it's a 1 pixel. It's a large macro piece. And so we really try to think about building these components so they'll fit together in flexible ways that don't constrain what you do. And you can see that when the components lock together in a finite number of ways, that's when you actually can see atomic features even at the macro scale. If you ever tried X-ray crystallography, you can tell things about the shape of atoms because they don't have much flexibility how they hook up. So even a big hunk of something, you can, if you look right, you can tell the atoms work because their pattern is exposed. The superstructure is defined by the substructure. So we've tried to do a good job in this, and we're going to talk through today and tomorrow how to do all these things. But that's what we're thinking when we do things. When we change things a little bit, and the API changes a bit, that's why we're doing that. We realized something we had done forced you down a road that you didn't want to be forced down, so we changed it. We don't usually boast, but I'm pretty immodest. We have but the way the API key works in maps, we know when people use maps. When people use maps API sites, because you have to the key gets used that first time. So we have a sense of how many times each key is used every day. And so we have a good notion, histogram-wise, over the course of a year, how many active, highly used API sites there are. And there are more than 150,000 active sites. So either people in this room are all of the Google Maps developers, and you've each done 300 or 400 sites, right? Or else there are a lot of people we don't see here who have active, highly used websites. And I think it's important because sometimes we have a chance to do interviews, and always the reporters, strangely, always want to imagine a fight in free enterprise. Like you can't just have a cheerful competition on a good product. They want to think you're fighting with somebody. They'll say, "Oh, aren't you worried about competitor X or Y?" And I'm always thinking, well, there's MapQuest and whoever. And there's say 20 of us, and there's 150,000 of you, And I always think of it that way. I think, well, I got a big team over here, and it was pretty exciting because when I described earlier that our mission is to organize the world's information, it's pretty much axiomatic that Google can't put its arms around all the world's information, nor can it provide the context that makes the information best expressed. So an example of that would be, imagine a website that was used maps, but it was about trails and paths for a weekend excursions. And it was like the, mother-daughter hiking site. So then you'd have notions about where to stop, where to get something to drink that were, spaced far enough, too close, not too far apart for a child. Be pretty comfortable and pretty relaxing. If there was a similar website, but it was for, say, Hell's Angels Motorcycle Club, then it would have different rest stops further apart. It had more beer, less, less Kool-Aid or something. It would just be different. So the fact that the sites were different is a kind of semantic web nature to the map itself. It's the same, mountain, but it's a different view on it, and it's through the view of a lens that data designed to be just what a little girl and her mother would want to see, just what, whoever would want to see on their motorcycle. And so that kind of specificity makes your essentially subclassed versions of our work more particular and more valuable to the smaller group, but they love it more. It's less generic. It's more specific. It's more valuable to them. And in some cases, it's the only way to reach those people. We built a Google Sky, for example, to show astronomy data in context, so people would actually understand with those little Hubble pictures where they go. They're not just like postage stamps; they actually are part of a bigger mosaic. But I wouldn't expect, real astronomers to rely on that as their astronomy tool. So, but there are astronomers who use our Maps API in the Sky mode to build tools for other astronomers. And it has, instead of left and right, it has right ascension and declination. It has just the lingo. The whole thing is astronomer talk, just like Hell's Angels talk. It's about the people that are using the map. So that's very important. And so I want you to understand, we don't look at the maps that aren't our maps as like a lightweight version of our map. It's actually the opposite. It's the professional version of our map for some targeted profession. And the profession could be Boy Scouts. It could be anything. And the next thing that I would talk about is that we have these 150,000 sites that are active API sites. We have many sites that use the static maps API and other things. But these are active. So there are a lot of people behind these. People are starting to see information in a spatial context. So we had a belief as engineers that, there's a whole web of information, a whole world of information beyond the web. And some of it belongs on a map. Some of it doesn't. Recipes maybe don't have a good map nature. You could say, these carrots from over here, they really taste good. But it doesn't really change the recipe itself. And so some things don't belong on the web or on a map, but other things do. And whether it's 20% belongs on a map or half, or more than half maybe, as some of us might think, it's a big part. The problem is, though, people are very familiar when they see a scroll bar on a web page. They know what to do to see the bottom half of a document. But when they see a map, they don't just, until Google Maps came out, they didn't think you could even, drag and something good would happen, right? So there was, the map was kind of east, south, east. Not that bad, but it's just the meaning of what your interaction with a map has changed. But as that changes, as people learn how to use a keyboard or a mouse or drag a map, then we can build tools, ourselves and you, that exploit that so they can have a better experience. And so this is a conceptual chart. It's only the chart with no data in it. If you think about contributions, say in terms of data or development effort from different classes of users, say from Google itself, from you in the developer community, or from end users like those people at KPBS, and you think of the result of that work, whether it's a web page that has a static Maps API, or a website uses Maps API, or maybe just some data, like the fire case. I think about how do these communities connect? There's 9 combinations here of things that we do that end users see, things that you do that other developers see. Some people build developer tools for other developers. Sometimes users actually help users, which is what I was so pleased about in the KPBS fire case, because nobody there, either using the fire information or building the map, knows the things that we know. And it turns out that the big problem they had with that, what really didn't work well, was that there was a problem in communication when people would call in from home. They say, my house is on fire. I can see it right across the street. I'm leaving. I'm taking the dog. I'm out of here. But here's my address so you can move the little polygon. They had to write that down on a piece of paper, and then somebody had to, there was no direct action on that. So just as soon as that came out, we launched this collaborative mind maps. So you could imagine now, if that were to happen again, and it's happening in Burma and China right now, people can kind of agree and think all the Red Cross people can edit the Red Cross locations, and all these people can edit those locations, export those as KML. So I think about things this way, and I've categorized a lot of things. I don't want to go into it, but I urge you to think about this transactionally. These 3 tiers of developers, they have either a kind of an aggregated single power, or they have a spread out pointed focus, or they have a kind of no power, but there's billions of them along each axis. And the way they interact has to be facilitated more and more as we go to the upper right. We have to give them the answer. So upper right was KPBS. It's kind of like upper right would be like a microwave oven used to make popcorn. You put the popcorn in there and you just hit popcorn, and it works. And that's a more targeted solution. So something I was thinking about. Now, the one thing that we haven't done in our rush to make things really, really useful, which for us has meant diversity, breadth of coverage, many languages, composability of the web, the real web as an application platform, not a captive thin runtime inside a web browser. But as we work on that, is we've had to leave some power behind. And for example, if you look in the Google Maps API developer blogs and questions, we get questions like, I got 300 markers and it worked fine in Firefox, but it core dumps in Safari sometimes. Well, that's true. Safari and Opera and Internet Explorer, they're all different, right? So I like to, you're mostly web developers, like to imagine there was no limit. Okay, you could have 300 markers, or you could have 300 million markers, and it would work just fine. Now, obviously, you wouldn't want 300 million markers on your map, and you wouldn't see them at the same time because all you would see would be like red, or blue or whatever. It wouldn't be useful. I don't know if you ever played Missile Command, the video game, but if you got a certain amount of stuff going, all it was this continuous cloud of explosions. So, same kind of thing. You can't have that with your map markers. But they could all be there ready to display. So, let's just take a moment to look through what you get if the power is basically unlimited. Our answer for that is called Google Earth. And what you get is you get a globe that's the shape of the Earth with the right eccentricity. You can zoom in smoothly, not step to magnify. When you move out, the tilt, like we're going to Cairo here, you can tilt. You can see roads. There's the pyramids. If they're 3D things, you can see them as 3D things. If you want to go to the Sphinx, you can see where all the pictures have been taken. You can read Wikipedia articles. You can back up and see where the pyramids are compared to Cairo. I'm going to go a little tour here and talk about this. You can pop across the Mediterranean. You can see the Parthenon, and you can see how it's laid out. It's got a very beautiful marble, and that marble was all mined on Pentelicon right there. It's Penteli marble. So all the marble at the Acropolis came from that little quarry. You can go see St. Peter's Basilica and really see it. Can't see inside the chapel roof, but you can see it. You may have heard of the Colosseum. You can see it in 3D. This is on my laptop computer. So what can we do? We can go see where Ben-Hur was riding around the Circus Maximus, right above Palatine Hill. You can see the first jail. It's called Carcer. That's what incarceration comes from. Let's see what's going on. We can go to Paris. Let me show you this. You see all the yellow rectangles. Those are all National Geographic articles. If you click on those, you can read the whole story. Exactly at the spot within 40 meters on average of where it was actually written about. You go to Tokyo, you can see almost every building in Japan in 3D. Some aren't textured, some are, but every building is there, even farm buildings. That's pretty cool. I don't know if you go to Tokyo like I do, but this is the Major League Baseball park, and the Yakult Swallows play there, but I saw them play the Ham Fighters, and the logo of them is the Hello Kitty. So these guys out there, with the Hello Kitty on their shirt, it's great. It's a very different character than here. They're very polite. Hello Kitty would approve of that. So here we have something that's kind of mysterious. That's the Buckingham Palace. That's the changing of the guard. But you see these circles. What these circles are, this is all released stuff in Google Earth. It doesn't look like an Ajax application. It's a little bit more powerful, right? More memory, some dynamic allocation, multi-threading. It's a little bit bigger thing. But it's still, this is what we're talking about. It's the world's information in context. Those circles are rings of all the books we've scanned that mention that location. The outer circle is the first one you see when you're up high in space. That's the first 25, that's the first page of web results, basically, the first page of books. If you click on one of those, you can read the book right there. Okay, for books that are not in copyright. That's the Old Globe Theater, and that's what it's like to sit in the Old Globe Theater. Those are stories about different places. I don't know if you ever saw the Prisoner TV show, but that's Port Merion. That's where Patrick McGowan strove to escape from for so long. He finally made that out. The Book of Kells is right there. One of the KML authors knows well that location. This is Jungfraujoch, is roof of Europe there, observatory. So this is Mount Everest. So the point of this isn't, wow, you can look at this, but it's pretty normal now when you see a map on a website, you think if you just touch it and drag, something good's going to happen. That's only been 2 years. Okay? This is the third Google Developer Conference. The first one, we launched the Google Maps API. The second one, we celebrated people were starting to use it. The third one, they use it like fiends. Everybody's using it. And people actually think when they see a map, they should be able to drag it. Otherwise, something's wrong. Right? It's dangerous to have just a static map on your website now. So, I think of a world where people would think this was normal. That's the world I want to live in. I want to do a Google web search, and I might see 10,000 results, and I might be able to see where they are. It would just be normal. It wouldn't be something special to go to the Grand Canyon. The fact that it existed meant you could type in Grand Canyon, and you would just fly there, and you would think that was just what computers were all about. Or if you want to go see Barry Bonds play baseball, you can fly there and see the game. So that's the world that we dreamed of when we started the product called Google Earth. And this is what people do every day. More than 350 million people use this to see the world. But, as pleased as we are with that, we have to admit, 350 million people is far short of the world's 20 or 40 billion web documents. Every page in one of those documents, there's the Guggenheim Museum, every page in one of those documents maybe needs to have one of these kinds of things going on in it. If you go to the Wikipedia, maybe you should actually see, some object. You should see it in context. You should be able to spin around it and walk into the pyramid and go see the interior decoration. You should click and fly out into space and do so smoothly. So that world of really live exploration is the world we dreamed of when we built Google Earth. It's the world that Larry, Sergey, and Eric dreamed of being married with the world's information when they bought Keyhole. And it's something we've always wanted to do. We've done, but we've always felt kind of slightly second class because we built it and we could program it, but you couldn't program it. Right? You couldn't do your magic. The 150,000 Maps API sites do things the Google Maps team didn't know to do. Wikimapia is great. All these things are great. We're proud. We're more proud of you than us. Google Earth doesn't have that ability to inspire other people because it's pretty sophisticated, compiled binary for machines, and our world has been as good as we could think to make it, but not as good as you could think to make it. And so the real thrill for me to be here today is to talk about something that we're launching, that we launched this morning, which is a Google Earth API. And it works. So, I don't know if you already knew that, but to me it's a big deal. Don't think we were like holding people back and not letting them use it. It wasn't like that. We worked really hard to make this work. So, this isn't the Google Earth entire program. It's the renderer. It's the 3D window of Google Earth, made as slim as it can be, but like me, it's not as slim as some people are. But it's really smart and clever, so maybe that makes up for it. What it is it runs in a web browser. It's installed in a plugin, one mechanism for Internet Explorer, one mechanism for Firefox. And there's the URL right there. And if you have a Windows PC and you're in the audience and your computer's on, you can just go to code.google.com/APIs/Earth and click, and you'll be flying around just like we were doing on your laptop right now. Okay? With one line of JavaScript, you can turn your Maps API site into what you just saw. You can control the layers. You can control the motion if you want to. You can do whatever you like. Real pleased with that. Now, what I'm not pleased about is in red. We're working really hard, and we didn't finish Mac and Linux in time for today. All right? We could have waited for next year. Right? That seemed stupid. We could have waited till later on in the summer. That seemed kind of refined, except that it was crummy because it took away something that worked today. So what we're doing is we're launching Windows only today. In less than 8 weeks, the team's commitment is that we'll have it running on Mac. And the Linux and Mac versions are almost identical, so we should expect Linux right after that. So since it's not kind of omni-platform, you might be afraid to link it in for fear that users would get a bad experience. I appreciate that. So think of it as a developer release for you. If you want to launch it, it's ready to go. If you want to hold back until it's multi-platform, that's your business. But it might make sense to find out now what the future is going to look like. Now, that future is not a future without maps, because like I said, engineering is about making choices. It's about trade-offs. So Google Earth, as this multi-threaded, magic flying thing, needs to cache more data in memory to do that. In Maps, if you click zoom in the button and it changes into a picture, we can load more tiles. We don't need to cache them ahead of time particularly. Earth does a lot of fancy stuff, pretty fancy stuff, so it needs more RAM to hold the stuff it does. It's not crazy. We put on a big diet to make this. So this works well with 5 or 6 Earth windows open in different browser windows. It works fine. But the first one you start in the day takes longer to start because it's got to do some allocation and get things ready. The second page you go to, it's just instant, but the first one takes longer, and there's a timeout. If you kill the first window and then an hour later you start another window, it pays the time again, and we're going to have an API to let you set that timeout. Right now it's pretty short, but it could be made 24 hours, in which case you only pay it once at boot time and you never see it again. But anyway, there's a trade-off in all of life. Let's see what else we should admit to. All the good stuff's in there. That's good. It's not the Google Earth program, so you have to separate the program from the technology, and it's really hard to do that unless you can see it. So let me show you. I'm going to push a button, and then something good's going to happen. There was the button. And now you can watch me log in. Okay. I love this so much, I went and borrowed a Windows PC so I could show you. Okay. That's not an anti-Microsoft thing. I just happen to like Macs a lot. Okay, so there's the proverbial web browser. And I had surgery on my eye a few months ago. I don't see too well, so I have to look closely. I'll come back. Okay. So if we make this not be full screen. You can see there we are, okay? And there's no downside to it being in a browser, and you can move around freely and so forth. So this is a Hello Earth program. What I want to do is show you what Control U looks like. Come on, baby, you can do it. There you go. That's the program. And you'll see something here about a map 3D, which you didn't see before. And it's maps instead of Earth, but it's Earth instead of maps, but it's like almost the same thing. Okay? Almost the same thing. Okay. But it's pretty robust how it works. And I'm not going to go through all this because good news for you is at 3 o'clock, you're going to hear all about it from Paul Rademacher. What? Plugin is required because we're doing unbelievable amount of stuff. Okay, so it may not seem like it's very sophisticated what Google Earth does, but it does things that Quake and Unreal can't do. Okay, so they're constantly streaming textures at 29 levels of a bitmap ahead of you. It's magic. It never stops to say, "Oh, you're in the elevator now while we're loading Tokyo." It never does that. It just goes there and it's sharp, right? So it's pretty tricky. You got to plug something in so we can fork off some asynchronous processes that let us do some stuff. It'll load the first time you go to the website, though. So one thing I want to show you, of course, I'm sure you believe everything we tell you because we're good guys from Google. But if you didn't, I wouldn't be mad at you. I would just point out to you that, this window and this window, they're all independent, and if I can toss them all at the same time, you'll see they really are. Okay, so you shouldn't be afraid to use this. You can turn on roads. This is all 3D terrain. You can turn on borders and show that when you zoom in and out. So it's a pretty robust thing. Works pretty well. And I'm going to show you one more. I realized the one thing you couldn't do very well with Earth is you couldn't build games because we built it to be a grown-up thing, but that just proves how unwise we were because games are more fun than grown-up things. So hey, it must be starting to get sour. I got to get with it here. So if I scroll down a little bit here, and I'm going to go to San Francisco. And what I like about this thing really can get some air. So if we go. We're just driving around the city here. This is not a reasonable thing to do, okay? But the thing I like about it is that it only takes a very little bit of code, okay? Okay, I just want to see, so you're laughing, okay? And here's the thing. How many mashups have you laughed at, okay? Isn't that great? See, it's more real because it's actually doing something. It's a human, okay? So it's a fun thing. You can look at the code for that. Paul can talk you through that. I just wanted you to see this notion that as much of the magic of Google Earth that we could fit into an API is in the API, and it's launched today, and you're welcome to use it, and I hope you will. Hope you'll amaze us with what you do with it. Okay. I got to go back now. Okay. 3 p.m. in room 2, which I think is that room right next door. Don't get lost, because you'll see how to actually do it. Now, I'm leaving that basically in your hands. The idea is that all these things we're building, we really built them. We have all these engineers building them thinking that you really will do something wonderful with it. And that's why we do it. We don't charge you. It's not a business for us. We really want to make the world a better place, and we think that information in context really could be that better place. Really, really could be. I believe it as much as Thomas Jefferson did. It makes a huge difference in societies. We see that all around the world right now, and it's a good difference to make. And I think there's differences you can make with products that use the Maps APIs and the Earth API now as well to qualitatively change people's understanding. I'm not asking you to make a better-looking map. I'm asking you to replace a Maps API with an Earth API. I'm asking you to think, what needed to be told that people didn't understand, that now they do understand because of the tools you've been given? Please figure that out, and please do that, because the world really needs that. Thank you very much. Now, we actually went pretty quickly, and we have about 10 minutes. And you don't have to wait to the very last bit, but if you have questions, I'll take them. And you can ask me anything, but you're probably better off asking me why and what instead of how. Okay? Unless it's about Earth. I can answer that. Any questions? Anybody? Okay. Someone's coming up. There's microphones somewhere, I think, or here. There's a microphone here and one there. So we have microphones, and if you have a question, that's great. And if you want to excuse yourself, that's great. That's, no problem. Okay? Yes, a man is walking to the microphone, and he has a question for all of us.
Can the Earth API work against the enterprise server?
That's a very good question.
Thank you.
The answer is at this minute, no, but there's no reason why it couldn't, and you should come and talk to us at the front of this room afterwards, and we'll figure something out. Okay? That's not a product commitment, but that'll help you personally for sure. Okay? I'm one strike against me because I didn't have a good answer for that man. Okay.
Right. One question I had is that how do you rank the relevance of information? I mean, one of the things I love about the Google search is that it knows who I am, it knows what's important to me. How do you incorporate that thinking into Earth?
Okay, so the question was about how do we rank things. Actually, I'd say that we're actually pretty poor by comparison to how good Google's web search is. So Larry and Sergey did a really good job on ranking documents. That it really is pretty remarkable. Out of 20 billion documents, you get the 3 that you really want. We aren't that good in Google Earth. We have a system where we take we scour the web looking for geospatial files like KML files, and we put them on the globe, and we have like the best of Google Earth the community and the other of Google Earth community, all that kind of stuff. And I would say we're not really good at that. We're pretty good, but not really good. And we done some research on that. We call it place rank, like page rank and place rank. But we're still learning. And one of the problems is the way the Google system works for web ranking is it relies on lots of data to do statistical inference. The number of millions of people sharing, clicking on a particular model in Denver is actually more specific, right? It's smaller numbers. So we have more noise mixed in with our data. I don't think we're as smart anyway, but even if we were, we don't have enough data to do as good at inferencing. So it's a research area. Okay? I'm going to try this out. I'll come back and forth. We'll go left and right here.
Any plans for a mobile version, either
Any
for
plans
Android or WebKit?
Is that Brady Forrest?
Yep.
Okay, so that's a good question. I would sure like it. I think if you I'm not going to answer your question, but I'll talk all around it. Okay.
That's what I expected.
If you heard Vic or if you've gone to any of the Android talks, you'll discover that Google has a tremendous belief, commitment, and investment in empowering a mobile internet. And our vision for that, perhaps simplistic, is that every good thing that happens on the regular internet should happen on your mobile device, right? And if the screen's not big enough for that, they should make bigger screens. Or we're not. It's not our problem. We just make the applications cool, and people will build whatever they need to build. So everything that's good on the internet, we think belongs mobile, right? So a better question is, when would that make sense, right? And when needs two things. It needs the confluence of sufficiently powerful devices, graphics hardware-wise, for Earth, and sufficiently stamina batteries when those devices are really doing something. Some of these devices, their burst mode, their sprint mode is great, but their jog mode is pretty weak. So what we in terms of power consumption, so what we do is Earth is very powerful. It's using every transistor is sweating in your NVIDIA processor, your ATI processor, right? They're all working hard. So that's good, but it runs through the battery pretty quickly. So when devices exist with sufficient power and sufficient battery capability, I think you should expect, as soon as we can make it work, you should see Earth and everything else running in that environment. And since we're making our own software for a mobile phone, you'd think we could do that, right? Okay. But it seems to be a hard thing. I think battery power is the biggest problem. Yes, sir.
You just kind of mentioned, but you didn't say anything about, maybe I'm looking through the sessions trying to find if there's a session about it. What's the Gdata Maps API? Because I can't find anything about it.
Michael, do you know what we're going to consult on the schedule here, and he will shout out Eureka in a moment, and go over there, and he'll tell you what the time is. I think it's this afternoon, or is it this morning? Tomorrow. Tomorrow. See, that's crowdsourced information. Tomorrow. I don't know who said it, but tomorrow. He said it with authority, so I believe him. What? My Maps Editing API. Okay, back over here.
Yeah, you gave us some nice tour of the world with some nicely populated urban areas. What about sort of the data that lurks sort of under the streets and sort of in the interstices? We sort of see it with Zillow kind of giving us a little bit of light on all that stuff that used to be in the dusty county records.
Yes.
And the facilities departments. And, real-time traffic flow, crowdsourced traffic, stuff like that. Do you see that as just naturally appearing here, or are there maybe bureaucratic or technical barriers?
No, that's a great question. In fact, that's the kind of question I deal with all the time that I wouldn't have thought this community was as motivated about. But the question is, there's lots of data. There's lots of information in the world that's not on the web, right? Libraries are full of really good stuff, better than what's on the web. Lots of movies are on the web. Well, certainly lots of GIS data, geospatial information from your county, from the government, from many sources is not available right now. What we have done is we built Google Earth. We achieved a kind of de facto, de jure global dominance in that space. And then we gave away KML, the fundamental data representation, to the Open Geospatial Consortium to be an international standard. And that happened over the last year. That is now an open international standard, not owned by us. And we edit that, and we vote. We get one vote. Microsoft gets a vote. Adobe gets a vote. It's one of those kinds of collaborative things. Universities are engaged in that. So that's helped a lot. Then we befriended, over the course of the last 2 or 3 years, Jack Dangerman, the owner and fundamental designer of everything about decision practice for ESRI, the Environmental Systems Research Institute. Jack was on stage at the WARE conference recently, WARE 2.0. And basically, we had a love fest where we said, all the data in the world is in his databases and normally uses his sort of captive world of description. And we're like the PDF reader for the masses, and we'd love to help, and we ought to work together. And we announced that would launch in 4 weeks. Well, that's been 3 weeks ago. So if you just look for ArcGIS 9.3 coming out any day now, you should be able to publish everything in there with just a checkbox you can hit, and it goes out as KML, it goes out as maps tiles. Unfortunately, it goes out as virtual Earth maps tiles too, but that's okay. It goes out, okay? And the key is that it's liberated. I don't, it's okay. It's out finally. It's out of jail and on the web, which is awesome. So the only thing left is the check mark whether a particular county wants to publish certain data, right? Clearly they shouldn't publish the, child molester. Maybe they should, but whatever they shouldn't publish, they shouldn't publish it, even if it's easy with a checkbox, and that's up to them. But so it's the technical part is actually bridged. You won't see that being bridged now, but within a month or two, people will receive their updates from ESRI, and it'll be bridged. And then the question is, will that flood the world with data? Will nothing change because the administrators are too frightened to click on the checkbox? I don't know. That's not my part. My part is to make the tool for them and then beg them to do it.
Of course, there are only 3,000 counties in the U.S.
I appreciate that.
Yeah.
But I've been at the National Association of Counties. For example, I was at the National Governors Association in D.C. a month ago, talked to all 50 governors, and said, look, you act like you're under siege from unknown threats around the world of all possible kinds. You have the greatest solution to all these things right in your hands. You have every citizen can actually tell you what's going on. They can say, hey, there's a guy doing funny stuff. They can tell you that. They had Alabama digitize their entire state and made it all live in virtual Alabama. Look that up. And I shamed them. I said, if Alabama can do this, realistically, right? Why can't New York and California do this, right? So I told them that at the governor's convention. So I don't know. I'm not a governor though, so I'm not. I don't have any street cred with governors. Okay, they were down to 7 minutes. So yes, sir.
I was just wondering if your new API is going to work with Sky data and such, or if there are plans to allow it to work.
I'm happy to say that it already works with Sky data, and one of the demos Paul will show you is the exact source code. In fact, it's already online. If you go to code.google.com/API/Earth, turn on and off Sky and fly to some Hubble pictures, it's already there. Okay. That was a good one. Better than the previous one I didn't know the answer to. Yes?
I've just spent most of the last 3 years in China, and
yes.
There's amazing things happening in China. Is Google Earth working with China?
Is working with China. So, does it work in China? Do we work with the People's Republic of China?
I don't know if
I'm not being cagey.
Could be defined that easily when it comes to China.
Fair enough. So you have been there for several years. Yes. SMSB, the state mapping bureau that runs all issues in China and makes laws about what's legal and not, has been really, really supportive. We work with them very closely, dealing with both a few months ago with this winter storm crisis, but more recently with this earthquake issues. We've been very, very busy helping in China with both providing satellite imagery, custom features. Google Maps in China are different source data than outside of China. But the teams working on that have worked really tirelessly, and all through Google, we're proud of these people who've mapped almost like they have the map of all the people that need things. They have the map of all the people that have things to give. It's like a matchmaking service. I need 3 mattresses. Well, I've got some mattresses. I've got water. Well, you need water. So it's really saving lives and helping. And the Chinese government's been watching that really closely, trying to balance. More information is more goodness, but it's also more scary to them. And so they're trying to balance that. Their balance isn't what we would pick in the United States, but I see it loosening a little bit. And I think actually engaging and saving lives, actually doing something has made a bigger change in the last 2 months than talking has made in the last 5 years. So, I think things are changing. I'll also point out that Wuhan University in China graduates, I think it's almost 2,000 PhDs in GIS every year.
The numbers in China are on a different scale.
It's on a different scale altogether. There's more people graduate with PhDs in geographic sciences in China than the rest of the world.
And
every year.
A great relationship with China is necessary.
I think it's a huge country with a lot of future. It's going to affect us all. Leave it at that. Okay. So I'm an engineer. Okay.
Do you have initiatives aimed at this sort of spontaneous collaboration that you demonstrated with KNPR?
We do. Actually, we added, after that happened, we added a feature to Google Maps, the My Maps feature, so you could share the ability to edit, so you could collaboratively edit things. So that's being used in Alabama now to do a lot of disaster work, preparation work. We also launched the meeting tomorrow, this thing, the Gdata Api. That's a way that you can write programs to basically be your own front end for that kind of collaborative sharing. So your, whatever it would be, could invoke that as a back-end service. And so that's a very powerful thing. And I didn't mention before, but as those data are built and edited in the Google Maps back-end, there's a real-time KML network link available, which means that any Google Earth client plus any Maps client can constantly be seeing the data as of a few minutes ago or a few seconds ago. So it's a live changing data source. So that's actually very unusual in mapping. It's really not something that you see in typical GIS products like ESRI and so forth. Okay, we have maybe one more question, and you have to ask it really fast. You have to answer it and hear it in 30 seconds. Okay.
So the ArcGIS 9.3 release is going to be very significant. Can you give us some benchmarks of the current amount of data so that a year from now we know just how significant it's been?
I can't. I would urge you to contact Jack Dangermond and ESRI and say, I want to know how serious you are about this. Tell me, because they're, for example, they're making it so that we can, our GeoSearch, which indexes all the KMLs and GRSSs, can index natively into all ArcGIS servers if the owner just clicks that button. It's all discoverable now by us. So, I would expect that basically 80% of the world's GIS data would be technically available if the owners of it click the box. I bet they'll publish only a tiny fraction of that. But the question is, if they publish it and something good happens with it, then there's a virtuous cycle. They'll do more. If people in this room ignore it and Google ignores it, they'll do less because it didn't get them anything. Okay, thank you very much, and please enjoy your next talk.